In the previous videos, we have seen the problem of externalities, using the example of the banana producers and the fishermen in Guadeloupe. And we have seen how private solutions, such as the Coase theorem or Coasean bargaining, may under certain circumstances lead to a solution to the problem of externalities. But we were left dissatisfied. So what about public solutions to the problem of externalities? In this video, we will see three types of public solutions. The first one is direct regulation, or as Stiglitz calls it, command and control. This basically requires the setting of standards, the mandating of technology, and the inspections, the monitoring and enforcement of those rules and regulations. The second type of solution we will encounter is what is called a Pigouvian tax. These are basically corrective taxes, such as carbon taxes, fuel duty in the UK, and you have read in one of the recommended readings, you have encountered the effect of the carbon tax on CO2 emissions in Sweden. The third type of public solution to the problem of externalities we'll encounter are what is sometimes called quantity-based regulations, or emissions trading, or more colloquially cap and trade type systems, and we'll discuss this in some detail. There are other solutions that have a public component. For example, enforced compensation, which you might have encountered in the ESPP readings, or the idea of subsidizing abatement, subsidizing filters, for example, which Stiglitz covers, and he's not impressed. We can also think about sort of forced disclosure of information type regulation that then work via reputation mechanisms, which we already encountered, and sort of ideas like corporate social responsibility to sort of voluntarily reduce pollution, for example, by companies. But of course, this only works for consumer-facing companies that might be penalized by consumers, and some will ignore these things altogether. So let's focus on direct regulation, Pigouvian taxes, and emission trading systems. The sort of most intuitively appealing and apparently most straightforward way to fix the externality problem is direct regulation, but the devil is in the detail. So let's think about the situation of the banana producers and the fishermen in Guadeloupe. There, the government could just step in and say you cannot use pesticides, or you cannot use more pesticides than what is needed to produce the efficient quantity of 38,000 tons of bananas per year. What's the advantage? Well, it's quick, it's straightforward, it's direct, it's widely used, and it is what happened in Guadeloupe, but it happened much too late. In practice, direct regulation usually relies on standards, and we're familiar with those when we think about sort of, for example, emission standards for cars or standards for toxic waste disposal. But we can also think about things like required technology, so safety technology that has to be in place, or health and safety regulations. So the government basically goes and sets certain standards that industry or consumers have to abide by. But identifying what these standards are and how exactly to set them is not so easy. There's also the problem of sort of imposing the lowest common denominator. If you're setting standards too low in a way, you don't actually get big benefits in terms of pollution reduction. You kind of avoid maybe some of the worst excesses, because there's no incentive to be cleaner. In the worst case scenario, you're kind of telling producers that as long as you meet the standards, you're good to go, when in reality we want them to, innovate and produce using cleaner technology. The more problematic part here, however, is information. You have encountered in the knowledge problem in the first week that aggregating this kind of information is really, really hard. So while we can think about sort of the banana plantations in Guadeloupe as sort of this micro example where perhaps we would be able to sort of step in and say this is how much pesticides you can use, in practice, looking at the economy as a whole across different sectors, finding regulation, for example, for CO2 emissions, is really, really hard. So it's going to be very, very difficult to do right by the different sort of producers that are exist in the economy. If the producers are involved in the standard setting process, they may also water down the standards and claim sort of big costs associated with compliance. So the information problems really, really loom large with direct regulation. Another problem concerns monitoring and enforcement. This is costly. In order to make sure that the firms actually, don't emit certain gases, etc., you have to send inspectors and you have to be willing to fine these companies, and the fines have to be high enough, and it may come to legal settlements, etc. So there's some cost to enforcement and monitoring. And the problems with fines can be that sort of companies treat fines just sort of as the cost of doing business. So the value of the fine multiplied by the probability of getting caught can be quite small. So these have to be very high in order to ensure compliance, and you need to invest into monitoring, because if the probability of getting caught is very low, this will obviously cause a problem. And this really relates to the last problem we have with direct regulation, and some other types of regulation, which is regulatory capture. I already mentioned companies may be involved in the standard setting process, but there are other problems with, that can exist there. For example, there's often a revolving door between industry and the regulator. And while this can have some positive advantages, of course, of knowledge, it of course creates problems in terms of the decision making of the regulator for the public good, or for the companies that these executives may return to or come from. This also opens the regulators up to another problem. They can be a play ball of politics, of course. So in the US, we have seen huge issues with Republican administrations basically trying to defund or very much limit the size and scope and effectiveness of regulators such as the EPA, the Environmental Protection Agency, or in the case of sort of market power and competition, the DOJ and the FTC. So in sum, direct regulation is all right. It is something we have to do for some minimal standards, and it is quite practical in many cases. But it's not an elegant solution like the corrective tax that you will see, or the emissions trading that you will see later, but there's a place for it in the toolkit, especially as in practice. Usually these different approaches work hand in hand. So you set some minimal standards to eliminate the worst excesses, and then on top you use a more effective sort of instrument like Pigouvian taxes or emission trading systems. What is a Pigouvian tax? Well, it's a tax named after French economist Arthur Pigou, and the basic idea is very straightforward. It's the idea of a corrective tax. All of you are familiar with the idea of carbon taxes. So in the UK, for example, there's fuel duty. It's a tax on gasoline consumption. But we can also think about tobacco taxes to reduce smoking, or sugar taxes to combat obesity, or in London, the congestion charge to reduce traffic in central London. The idea is completely obvious. You basically tax the thing you want less of. You try to tax the consumption activity or production process, which causes the externality to reduce the amount of the good produced, so that there's less of the externality, be it pollution or obesity or whatever the outcome is that you're trying to fight. So how would this play out in our running example of the banana producers and the fishermen in Guadeloupe? Look at the graph. If you look at point A, this is the current sort of output produced by the plantation owners. Why? Because it is the quantity of bananas that maximizes their profit, right? So they choose exactly the point where the price equals their marginal private cost. So how do we get from point A to the point where the to the Pareto efficient quantity, down to 38,000 bananas? we know that the producer's marginal private cost at the efficient quantity of 38,000 bananas is $295, less than the $400 that they earn for each additional ton of banana sold. But at the efficient quantity, the marginal social cost is also $400. So the external cost at this point is $105. Now, if the government were to introduce a banana tax to the market, a banana tax of how much? Well, a banana tax of $105 per ton of bananas. What would happen then? Well, $105 is exactly the difference between the marginal social cost and the marginal private cost faced by the plantation owners at the Pareto efficient quantity. So, by artificially reducing the price of bananas that the plantation owners receive from $400 to $295, we basically make sure that they choose a quantity of banana output that is equal to the Pareto efficient quantity of output that we want. We know that the plantation owners maximize profit. They maximize profit by finding the quantity that at which the price, the revenue for an additional ton of banana sold equals the marginal private cost. And together with the tax, so the after-tax price of bananas being $295 per ton, this point that they choose, this output level, is exactly P1, is the 38,000 tons of bananas. So the tax is able to correct the message conveyed by the price of bananas, and the plantations face the full marginal social cost of their decision and produce less bananas. Pigouvian taxes, like our banana tax, are a great tool to correct externalities, partly because they are less draconian than outlawing things. And it is no surprise that they are very widely used. We all are familiar with the idea of carbon taxes, such as fuel duty in the UK. So how do they compare to the other approaches? What are the pros and cons of Pigouvian taxes? Well, the information problem that we encountered when we talked about regulation, of course, still persists. The knowledge problem hasn't gone away. In the toy example, it was really clear that we would set the banana tax to exactly $105 per ton of bananas. But of course, in the real world, that's not going to be so easy. We don't know what exactly the marginal social cost of these activities is. So we may end up setting the corrective tax too high, leading to underproduction of the resource, or too low, leading to still overproduction of the resource and still incurring the external cost. But the knowledge problem looms less large than in the direct regulation framework, because we can apply a uniform rule across all sectors, across all producers, without having to know details about each individual producer or firm. Similarly, there are still monitoring and enforcement costs. The producers still have to be made to pay the tax, especially if the tax is applied on some output that we want to prohibit, like the pollution levels or the carbon emissions. But there's a trick. We can often tax inputs. Taxing inputs often lets us reduce those monitoring and enforcement costs dramatically, and this is quite important. Think about the example of fuel duty and carbon tax or gasoline taxes. All the state needs to do is tax oil or refined oil, so gasoline, at the point of the refinery. That's it, done. Compare that to a regime of inspection or some setup where you try to estimate individual car consumption of fuels. Pigouvian taxes also, of course, have nice incentive effects. So they basically create an incentive to reduce pollution in the future. And that's good for innovation. Think about cars getting more fuel efficient. Think about production processes that are run with less waste, if this wasteful process is taxed. This rewards sort of the innovators that are able to come up with ways to produce goods or consume goods in the case of consumers without actually producing the externality in question. Furthermore, while the tax is introduced to correct the market failure in a specific market, and in our toy case, for example, reduce the output of bananas, there's another effect. This is what some people call the double dividend. Well, it raises revenue for the state. And this means we can use the revenue that we generate from the corrective taxes to reduce other sort of more distortionary taxes, for example, on labor. So what are the problems? Well, there are some problems. Well, first of all, it is a rather blunt instrument. So there may be the need for some exceptions. There may be some producers or some sectors of the economy that are not viable if say, carbon or gasoline taxes applied uniformly. So in the UK, for example, there's this phenomenon of the red diesel, right? So some gasoline, some fuel, diesel fuel used for construction activities and for farming is taxed at a lower rate than the gasoline consumption for sort of the end consumer. But of course, this sort of potential need for exceptions creates issues around political feasibility. It's going to be hard to distinguish the genuine concern for the viability of certain sectors from sort of the whining that the politicians will get from producers hurt by the Pigouvian tax. And the argument that the corrective tax, whatever it is too high or hurts the particular sector or companies, especially if they are located in a specific politician's constituency, for example, of course will find open ears among politicians, and there will be an attempt to perhaps interfere with this process. A big example in the UK is fuel duty freeze, which has been in place since 2010. The UK set up a system where fuel duty, so the carbon tax for car gasoline, was basically set to increase every year. But politician and chancellor after chancellor has announced, full of enthusiasm, that they have given a great gift to the British motorist, in the sense that they have not increased fuel duty yet again. So it has become a political play ball, when in reality, of course, we want the sharp edge of the corrective tax to work. And so for this momentary popularity, when the Chancellor present their budget, we all have incurred a huge cost in terms of the actual cost, in terms of lost revenue for the state, but also in terms of increased CO2 emissions due to overconsumption of gasoline. We should by now have a pretty good understanding of how Pigouvian taxes work and what sort of the advantages and drawbacks of this tool are. What I want you to do now is to pause the video for a minute or two and think about other examples of corrective taxes. How many can you come up with? Did you come up with some good examples of corrective taxes? Now, the question, of course, as I asked before, is, so does it work? Do these examples that you just came up with work? Do the carbon taxes we've mentioned before work? Well, economic theory can't really give you the answer to that. It can point at potential problems and potential gains, but in the end, these are empirical questions. In this week's required readings, you encountered the Anderson article on carbon tax introduction in Sweden. And he uses a reasonably fancy method called synthetic control method. Some of you will learn about it in advanced quantitative methods, I think. But basically, what does he find? Well, he finds that the introduction of carbon tax, or increase of carbon tax in Sweden, had a big effect on CO2 emissions. He finds that there's an 11% reduction per year in CO2 emissions in Sweden due to the introduction of this corrective tax. So, Pigouvian taxes are a powerful tool and they should be widely used. So we have learned about two mechanisms to solve the externality problem: direct regulation and Pigouvian taxes. But there's a third option that I want to introduce today. And this is the idea of emissions trading, or quantity-based regulation, if you want a fancy word, or marketable permits in the Stiglitz book, or more colloquially, cap and trade type systems. These are systems that basically play sort of a form of jujitsu, if you want. We kind of use the market to our advantage to correct the externality by setting up another market, a second market, if you want. And that's a market for pollution, a market for emission permits. So how does it work? Well, basically, you require firms to hold permits in order to pollute. So any industry, any firm, any power plant or factory that emits CO2, for example, has to hold permits equivalent to the amount of tons of CO2 that they emit per year. How do you get the permits? Well, basically, the government sets up a mechanism to trade those permits on some sort of exchange, okay? And so once the permits are in place and the trading system is in place, basically firms will buy permits if the price of permits is less than the marginal private cost that they face in terms of the production. And they will sell permits if the price of permits is higher than their marginal private cost of production. And this trading between firms that are better or less good at avoiding pollution in the process basically leads to an equilibrium in this market where firms reduce pollution to the point where the marginal cost of pollution equals the market price of the permit. And this is really quite clever because it aligns incentives. So basically what happens in this situation is that the sort of most cost-effective reductions in pollution are done first, because the firms will find those. They will try to maximize profit by either reducing pollution or by buying those permits. So the firms that are best able to reduce pollution through innovation in their process or through reduction of their output will do it first. And so it's basically like a reward for the more efficient and more clean and more innovative firms. Another advantage of this kind of setup is that rather than trying sort of to guess what exactly the right tax price is that we should put on the pollution causing activity, we just set sort of a maximum quantity of pollution that we want to accept, that we want to tolerate for the production of the goods that we want. So the government basically sets up the level, the quantity of emission permits that are in circulation equivalent to the desired level of pollution, and the market sorts out the rest. And usually you start basically with a setup where you start with a status quo situation. So you assign permits to the companies that are already polluting. You don't want to sort of change everything from one year to the next. So you try to mimic the status quo and then sort of step by step reduce the amount of permits available or the cost, or try to increase the cost of the permits. And a great example of this is the European Union's emission trading system. So let's look at that in some detail. The European Union's emission trading system for various sort of harmful gases has been in place since 2005, and it has sort of operated in three phases. There was an exploration or sort of trial and error kind of phase, and you'll see there were some errors initially, and there were three phases until now, and the fourth phase is starting next year. So how does it work? Well, exactly like the sort of emissions trading system I just sketched. The firms have to hold permits in order to pollute, and they can trade those permits on a marketplace. So what would we expect this to look like over time? Well, the goal is the reduction of CO2 emissions, right? So by reducing permits over time, we would want the price of CO2 emissions to increase. So the price of the permits should increase over time. Yeah. So how does it look over time? On this plot, you can see the time on the x-axis and the price in euros per ton of CO2 emissions on the y-axis. And instead of the sort of linear gradual increase that we were hoping for, we see pretty chaotic volatility type behavior. Now, what's going on here? Well, the biggest surprise is probably in the beginning. So I told you that there was this phase where they were kind of experimenting with this, see how it works. And it turns out that was a good call because it didn't end well. Essentially, what happened is that the price of carbon emissions dropped to the floor from the sort of initial allocation. What happened? Well, basically the producers lied. So the expectation of what the cost of CO2 emissions should be was much higher than it should have been, and basically the market price for CO2 emissions collapsed, and that's not what we wanted. But sort of in the phase two, it kind of started to work a little bit. But what happens then? Well, we can also clearly see the 2008 recession. So one maybe underappreciated side effect of an emissions trading system is that if business activity tanks, the price of the permits, the price of pollution goes down as well, just because there's less production in general for other reasons. And that's not what was intended. So over the sort of great financial crisis, recession, Euro crisis, we actually see the cost of CO2 emissions fall over time rather than increase. Okay, but if you look towards the end of the graph, there's actually some positive news. So the cost of CO2 emissions, the cost of the permits is actually increasing up to today. But what do we expect to happen given the pandemic? Well, we probably expect another crash, don't we? So two important lessons to be learned here. One, the initial allocation is really difficult. The process that was set up by the EU in terms of sort of some free allocations to sort of industries that need to compete on the world market and then some auction component, it didn't quite work. In general, this is one of the fields where probably an auction-based system is better, which has the additional advantage of sort of generating revenue, of course. The other lesson learned, of course, is like how strong the effect of the business cycle is on production of CO2 emissions. And that is something that the emissions trading system has to take into account in some form. That being said, there are some people that argue that this is actually a benefit because it acts like an automatic stabilizer on the economy. This is one way to lower the burden on firms in the moment of a recession. But I'm not sure the environmental economists would agree. So what's the verdict on the emission trading systems? Well, it's very widely used by now. Most countries have set up similar types of exchanges, and it is a fantastic tool because it basically uses sort of the power of a market, a second market for permits, to our advantage. What about the problems that have plagued the other solutions to the problem of externality? Well, the information problem hasn't quite gone away. There still is a sort of this problem of knowledge, of the decentralized information, of the marginal private costs of the polluters, for example, being unknown to the government. But this is much less of a problem with emissions trading systems because it essentially only matters for the initial allocation. And that is one of the sort of lessons we really can learn from the initial failure of the ETS system, is that you don't want to hand these out too easily, too freely. This is where auctions really can play a great role. And we have seen this year a Nobel Prize going sort of to these economic engineers, if you want, of how to run these auctions. And there was some criticism of this, of not answering the big questions of society or something like this. But designing auctions that work well under these circumstances is a tricky business. So it is very useful to have these tools at our disposal. Another problem that relates to sort of the availability of information and the initial allocation is that there are going to be some sort of effects of the sort of transition into the system. Basically, there may be some firms that were doing the right thing. They were trying to clean up their process already, and they may not be rewarded for these prior sort of pro-environmental investments if it's not auction-based, if it's sort of allocation-based. Are there still monitoring and enforcement costs? Sure, we have to make sure that the firms actually possess the permits to pollute, and there will be some that avoid this. But this is, of course, much less problematic than sort of trying to ascertain the compliance with standards in the first place, because it is probably in many cases going to be cheaper for the firm to just comply with the law and buy the correct number of permits rather than face the probability of fines. How about incentives to reduce pollution? This is where these emission trading systems really come into the fore. They are very strong. There's a strong incentive for individual producers to reduce their either their output or to change their production process to reduce pollution, because they can save money this way. So we are trying to really price in the cost of the pollution, the external cost. And this is really good for also things like innovation, because firms can, of course, make money by selling those permits. So if they're able to generate their output while causing less pollution, they can then sell on their permits to other companies. But we've also seen some problems. One obvious one is the sort of strong business cycle effects. Like I said, some people believe that this is actually a feature, not a bug. So it acts like an automatic stabilizer on the economy. But of course, it means there's going to be then sort of more pollution than we would normally want given the level of output, which doesn't seem quite right. So we should maybe combine the emissions trading system with a price floor in the market. And I think there are many of these sort of economic engineering type ideas that can still be exploited to the good of society, to reduce pollution, to internalize the externalities. One specific problem of emission trading systems, though, which it shares with things like the Pigouvian taxes, of course, is what if the location of the pollution matters. So usually it doesn't distinguish between where the pollution occurs. So you can buy permits to pollute maybe in areas where we would rather see a reduction in pollution. So how about those dreaded questions of political economy and sort of political feasibility of the system? Well, it's quite ingenious, I think. There are huge issues around initial allocation. There's going to be mismanagement, there's going to be information asymmetries, what we know as lying, and there's going to be sort of political influence. There's going to be all sorts of things going on. So the initial allocation of permits is really difficult. But once the system has been set up, even if we can perhaps introduce it sort of at a low price, without doing too much harm, without getting anyone too excited about it. Once the system is in place, you can turn the screws, and you can turn them slowly but surely in order to slowly increase the price of the, for example, CO2 emissions or whatever harmful pollution you want to reduce. And you can do this without sort of raising taxes or the introduction of new standards or anything else that creates sort of political turmoil or political constituencies, if you want. It's just sort of a gradual tightening of the screws on those polluters. So I think that this political feasibility is one of the really clever features of emission trading systems. But as always, we have a great system here, but what's the empirical evidence? What does it look like? Is it successful? Well, the ETS, despite all its failures in terms of the initial allocation, actually has been estimated that it has led to sort of a 20% reduction in CO2 emissions between 2005 and 2020. But so, there's some success, but of course these sort of business cycle effects, for example, are a problem. That's why in the next video, we will look at how the UK has been successful in reducing the use of coal to produce electricity. And it has basically used some features of the emission trading system plus a price floor to achieve this.